Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The topic is Nonlinear Partial Differential Equations of First Order, Standard Form 6. Definition of partial differential equation, dependent and independent variables, Standard Form 6. These three topics we are going to discuss in detail through this lecture. Partial differential equations. The equation which has partial derivative. If it has partial derivative, mathematically how it should be written? So the representation of partial derivative, the symbol dou is a partial. If it has one or two partial derivatives, it is called, simply we can call it as PDE or partial differential equation. So dou z by dou x or dou z by dou y. So here x, y, z. Here x and y are two variables. They are independent variables. Coming to the picture z, that is dependent variable. So this partial equation, at least one dependent, at least two independent variables it should have. The notations are dou z by dou x, it is denoted by P. Dou z by dou y, it is denoted by Q. And dou square z by dou x square, it is represented as the variable R. Dou square z by dou x dou y, it is small s. Dou square z by dou y square, it is nothing but it is represented as T. That is, these three are second order. Two times we have to do the differentiation. Whereas these two we have to do only one time, that is first order. So nonlinear PDE of first order. So the PDE which involves first order partial derivatives. Compulsory P and Q. Now only dou z by dou x it is there. It is first order linear equation. But whereas dou z by dou x, the whole square it is there. Then it is first order, but the degree is 2. That means higher than 1. Then it comes under non-linear. The first one is linear, second one is non-linear. So the product of P and Q is called non-linear partial differential equations. Standard Form 6. The equation is of the form. Now we can see it. F of P into Z power n, comma, Q into Z power n, which is equal to 0. Suppose P into Z, that combination is very important, and Z should have some powers. Q into Z, that combination, the n, Z should have some power, and the power, that is n, the n is nothing but constant. That is, it's nothing but, in this way also we can tell, the given equation can be grouped in such a way x and p z power n, otherwise y, comma, q into z power n. This is the way also the standard form 6, the notation. The above, the form of the equation which is transformed to, this is our standard form 6. This notation is transformed to another form, that is this form. So standard form 6 we are, the 6 is reduced to standard form 3. That is standard form 3 it has P, Q, X, Y. Strictly Z is not there. That we have to keep it in our mind. And two cases are there. Case 1, that is n, the Z which has the power n, the n is not equal to minus 1. One case, that is capital Z, we will assume as Z power n plus 1. If it is equal to minus 1, we will assume capital Z equal to log Z. These two cases we have to remember. Yeah, we have taken one problem. So the given equation is, so it is written, just we have taken Z square inside. So Z square into P square, Z square into, Q square should come here, Z square into Q square. So it is written as it is, the right side, X square plus Y square. Now, just we did the simplification. ZP the whole power square, ZQ the whole square. The right is written as it is. We named it as 1. Is it necessary, this simplification? Yeah, it is compulsory because our standard form 6 is P Z power n Q Z power n. That is P Z, yeah. Then the P should have the power plus 1. But here the P is having the power plus 2. Here Q is having the power plus 2. Whereas the standard form 6, this is the formation. That is P into Z will be having the power. Q into Z will be having the power. In the n power also two cases. Equal to minus 1 one case, not equal to minus 1 another case. So to satisfy this standard form 6, our given question is modified in such a way, and we modified, we named it as equation 1. So the given equations now comes under, this is a standard form 6. Yeah, it is satisfied. Now it is written. We are noticing what about Z, because we know it. P Z power n Q Z power n is our standard form 6. Z power here, what is here? Here Z power is what? It's nothing but plus 1. N is playing the role plus 1. So which condition? Two cases we have. N equal to minus 1, N not equal to minus 1. Now our given problem falls under this form because our N is plus 1. According to that, we have to assume capital Z equal to Z power N plus 1. So N place, we substituted our given problem N value is 1. So 1 plus 1, it's nothing but capital Z equal to Z square. Differentiate both the sides partially with respect to X. So now we can see it. So we got it, capital Z equal to small z square, we got it. This side, it's nothing but dou capital Z by dou X. Here, Z square is there. The differentiation is, we know the formula, x power n, n into x power n minus 1. So, Z square, n equal to 2. So, we are putting 2z, 2 minus 1. Again, z we are doing. The differentiation is dou z by dou x. Because z is playing the role of dependent variable. Next, this notation is capital P. Small p notation is dou z by dou x. So we have to be very careful. Small p equal to dou z by dou x, capital P equal to dou capital Z by dou x. The 2z is written as it is. Yes, capital P by 2 equal to zp. Now, we did so far differentiate both the sides partial with respect to x we did. Now with respect to y. So dou z by dou y equal to 2z dou z by dou y. This is nothing but capital Q. This is 2z, it is written as it is. This notation is small q. So the 2 we are bringing this side. It has become q by 2 equal to zq. We know the equation 1 is this one. We got it already. That is zp equal to capital P by 2. Now we got it zq equal to capital Q by 2. We framed here this one to substitute this purpose only. The simplification also done to make here to substitute comfortably. So now Zp, which is replaced by our capital P by 2, and Zq, which is replaced by our capital Q by 2. Yeah, we replaced it. Zp is replaced by capital P by 2. The question square is there. So again it is retained. Zq, yeah, capital Q by 2. The square it is retained as it is, equal to x square plus y square. So here it is written. Now this form it is there. And this x square we are bringing towards left side. So minus x square. The y square here, this it has become here. So minus q by 2 the whole square. So the above equation comes under standard form 3. So we can see it here. The standard form 3, f of capital P, capital Q, x, y. This is standard form 3. Z, it won't play a role. Yeah, standard form, our 6, which is reduced to standard form 3. Now, according to standard form 3, what is the steps to be followed? The steps are P and X grouped to one side, Q and Y, they are grouped in another side, which is equal to some A. That is the step of standard form 3, and we have to solve P and Q, and we have to do the specific integration which will give the required solution. That is the steps of this standard form 3. Yeah, it's fine. Now this is written again as it is. Yeah, it is written. So f1 of this is according to our standard form 3, f1 of p comma x, it is according to our problem, which is equal to a square, that is some arbitrary constant. Next, f2 of q comma y, that is according to standard form 3 step, this is written as it is, equal to some constant, arbitrary constant. We have to solve P and Q. So this it is written here, and P square by 4, P square by 4 minus x square equal to a square. So P square minus 4x square equal to a square. This 4 also coming here. That's what. Here the steps are very clear. 4a square. This minus 4x square coming this side. It is becoming plus 4x square. In these two terms, 4 is common. So 4 of a square plus x square. So we got actually this term we are simplifying. We got it 4 of a square plus x square, that is p square equal to, we got it, but we wanted what is p. So we will find the square root of it. For the square root is 2. We have taken it outside. So we got the value capital P equal to 2 into square root of a square plus x square. Similarly, now we have to do what is q. Yeah, this is the thing according to our problem. So 4y square minus q square, that is here the divided y square minus q square by 4. So we are taking the LCM. So 4y square minus q square, which is equal to a square. This 4 is coming this side. That's what it is written here. 4 is common. So 4y square we are bringing here. So 4y square minus 4a square equal to q square. 4 is taken outside. We want it to q. So q equal to square root of 4 of y square minus a square. So the square root of 4, it's nothing but 2. So 2 into square root of y square minus a square. So P and Q, we got it. Next, this is the step of standard form 3. Capital Z equal to integral P dx plus integral Q dy plus C. So what we got it? The P it is substituted and Q we substituted. The number, the 2, it has kept in front of the integral. It is there. And the ready-made the formula which is available, the integral, the square root of a square plus x square, this is the formula. X by 2, this 2 is written as it is, x by 2 square root of x square plus a square by 2 sine h inverse x by a, plus this 2 is written as it is, y by 2, this integral y by 2 square root of y square minus a square by 2 cos h inverse y by a. Next step, we have taken the 2 inside. So 2 into x by 2 cancel 2, only x we got it. And here also 2 we are bringing, 2 cancelled. Here also only a square. The same here 2, the 2 cancelled, only y. The same here also 2 we are bringing here, 2 cancelled. This is the required solution. We will come to one conclusion. What is partial differential equation? So PDE we will call in a short form. The symbol is dou. Compulsory the equation which has the partial derivatives at least one dependent variable and at least 2 independent variable, then it is partial differential equation. So dou z by dou x or dou z by dou y. Non-linear. These two are first order linear. Non-linear, dou z by dou x the whole square, because the degree is higher than 1. Then it is non-linear partial differential equation. This is the form of standard form 6, that is P into z power n, comma, Q into z power n. Here two cases are there. N equal to minus 1, one case. N is not equal to minus 1, another case. Then the standard form 6, some steps we will follow, which is reduced to standard form 3. According to standard form 3, this is the formation. The steps for standard form 3 is we have to solve P and Q, and we have to substitute the value of P and Q in this integral form. After integrating, what we are getting, that is the required solution. So in this video lecture, we discussed in detail about standard form 6. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.